Hello friend, this is Professor Ghanshyam Rathod, and in this video we are going to see negative series negative shunt clipper. In last video we have gone through the negative series clipper. Now I'll draw this circuit. Negative shunt means the diode will be in shunt with the load resistance. Now I'm drawing it properly. So over here I'm just going to draw that diode part. This one is load resistance or source resistance over here. So diode is cathode terminal here. Diode is in shunt, you can see, and I'll draw the other components. This is source. This one is a load resistance RL. So positive, negative, B input. This is positive and negative I have written for positive half cycle. Will provide the sinusoidal input over here. I'll draw the input signal. This vertical is for voltage, V input, amplitude of the voltage, and this is horizontal axis for time. And line with that I am also drawing the output waveform. This is for V output. I'm writing the notations. This is V input, this is time, this is V output, and this is also time. I'm drawing the signal. This is a sinusoidal input signal. The positive half, negative half, positive, negative. Let me draw the alignments. The proper alignment, I am drawing this one. This is for positive half, this is for negative half, positive half, and this is for negative half. Now once again I'm going to give the notations. This is suppose T1 time, T2 time, likewise over here T1 and T2. Now for the positive half cycle, current will flow like this way. So this is negative, this is positive, so positive here, negative here. If we check the condition, if Vp minus Vn is greater than 0, the diode is in forward bias, or you can say it is on. And the second condition, if Vp minus Vn is less than 0, the diode is in reverse bias, or you can say it is off. Now if you check in this circuit, in this one, negative terminal is positive and positive terminal is negative, so definitely we can say the diode is in reverse bias. So if you draw that circuit, the diode is open circuited. Let me draw that. The diode is open circuited, or you can say it is in reverse bias. So here it is reverse bias, so switch is on, or you can say switch is off. And over here that is components. So this is source resistance, this is our load resistance RL. Now we'll check for this V input positive half cycle. The diode is in reverse bias, so current will flow like this way. And over here we are checking our V output signals, so equal to I into RL and equal to nothing but V in. So this is what you will get the output value. V output is nothing but equal to V in. Over here if you apply the KVL, you will also get V output equal to V in, where the source resistance need consider equal to 0, almost near to 0. So you'll get that V output equal to V in. So we can draw that output signal for the positive half cycle. It will be like will follow the input, so it will be positive. So whatever Vmax over here, you get Vmax positive over here. And this is what for the positive half cycle. Now if you take the negative half cycle, what will happen if I take the negative half cycle? Now you see, for the negative half cycle, the polarity will differ for the input signal. So now let us check for the negative half cycle. It will be anti-clockwise. It will be anti-clockwise. So this is what positive for the negative half cycle, and here positive, and this is a negative. Now you see, when this kind of anti-clockwise supply is given, or you can say negative half cycle provided, but this condition is going to get fulfilled. At that time, diode is going to get turned on. If the diode is going to get turned on, it is in forward bias. So you can draw like this way. So diode is in forward bias, or you can say it is on. So at that time, this polarity change according to the input supply. This is a positive, this is a negative, and anti-clockwise supply is given. This anti-clockwise current is moving. Now from this circuit, if you consider this terminal, this is nothing but short circuited. If you can give the notation, if A and B terminal are short circuited across the load terminal, what will happen? The current is going to get flow maximum, but the resistance between this branch is ideally 0. So for that one you can consider this one as a 0. So ultimately our output across AB terminal will be 0, and that is nothing but output across, that is what nothing but our output voltage. So over here, if you check this over here, that will be 0. If I draw in a different color, that will be 0. And once again, if the cycle repeated, we'll get this output positive. So you can see from the diagram, if you consider the negative half cycle, it will be 0, and positive half cycle output will equal to V input. So once again, the cycle is repeated. Likewise, if you see this name title, the negative portion of the negative portion of the waveform is removed. That is what, at the output side, negative portion of the waveform is removed, and it is a shunt one. So diode is in shunt with the load resistance. So here I hope you understood the negative shunt clipper. For the upcoming circuit, we will see the bias negative positive clippers. Thank you very much.